Hi there, welcome to 1.30, which is all about how glycosidic bonds are made. So, glycosidic bonds are found in carbohydrates. Okay, so what they do is carbohydrates. What they do is they join sugar molecules together. So, for example, glucose. Now, first of all, if we were to get two glucose molecules, draw them simply like this, and we add them together, the point where they're joined, just there, that join, just there, is a glycosidic bond. Okay, that's where our glycosidic bond is formed. If you were to write that as a sort of equation, you'd say glucose plus glucose makes a disaccharide. In that case, that one is called maltose. All right. Now, these in that case are the reactants, and this is the product. Now, there is actually another product which we'll come to in a moment. Now, when we join them together, we obviously draw our arrow going that way. However, you can obviously break maltose down, turn it back into glucose molecules. So, really, we should draw a reversible arrow, like so. And then we need to know what those reactions are called. So the joining together reaction, when the two glucoses are joined together to make the disaccharide. Okay, so maltose is a disaccharide. And these are obviously monosaccharides. When you're joining them together, that's called a condensation reaction. And when you break them apart, when you go back the other way, that's called a hydrolysis reaction. Okay, so condensation reaction joins them together, forming the glycosidic bond. Hydrolysis reaction breaks them apart. Now, we said there's actually another product formed. Now, when you get condensation on your windows, you know how you get water on your windows. Now, this reaction also produces a molecule of water, which we might draw something like this. And so if we were to write it in words, the products are the disaccharide and water. And sometimes exam questions do ask us what are the products, and people do forget the water. So don't forget that it also makes water as well. If a condensation reactions are happening, joining these two monosaccharides together to a disaccharide, it produces a molecule of water. If we've got a hydrolysis reaction, then our disaccharide and our water molecule join to make our two monosaccharides. So the hydrolysis reaction uses water, hydro like water, and the condensation reaction produces a molecule of water like condensation on your window. Okay. Let's just try to do a reminder from the last spec point, which I just went through, the names of the disaccharides again. So there I just said that that one's maltose. Now on here you can just see my little way of remembering the names of the disaccharides. So I remember my great-grandmother, M for maltose, is made of G and G, two glucose molecules. Then I remember silly green frogs, so the S for sucrose, that's the disaccharide, is made of glucose and fructose. And then the last disaccharide, lactose, is made of glucose and galactose. I don't have a way of remembering that, it's just because lactose is in the name galactose anyway. Remember that you only need to be able to draw glucose But in an exam, they might give you the structure of fructose or galactose, and you have to just join two of them together, or join one of those with a glucose to do sucrose or lactose. But don't learn the structure of fructose and the galactose. If you need it, they'll give it to you. The only one you need to be able to draw yourself is the glucose. So let's have a look now again at drawing our glucose molecules. So where did we draw glucose? So this alpha glucose molecule that we did in the earliest point, in the glycosidic bond formation, we're going to join two of these together. All right, so let's go back. Oh, I don't think it'll be add anymore. So what I'll do is I'll clear that. Just draw it. So first of all, we're going to have two glucose molecules. So oxygen, then we've got our six-sided shape. Carbons on the other corners. Carbons need four bonds. So I'm going to do maltose. I'm doing two alpha glucose molecules. H at the top, OH at the bottom. These two are different, so leave those out. These two are the other way, so H at the bottom, OH at the top, H at the bottom, OH at the top. And remember, this one's not just OH, it's CH2OH. Okay. Now, usually, just for the sake of completeness, we would draw that CH2OH over. So it's the C that's on there. Okay, now we need another one over here. So oxygen, carbons on the corners. Four bonds on the carbons. H, OH, H, OH, H, OH. Then these are the other way around, so H on the bottom, OH on the top, H on the bottom, CH2, OH. Right. The first type of exam question is they're going to ask you they'll probably draw this for you and just ask you to circle where the water molecule is going to be formed when you form a glycosidic bond. So it makes H2O. So you just need to circle this. So you can see that within there, we've got, no, OH isn't very clear, two hydrogens and an oxygen, because water is H2O. Two hydrogens, sorry, two hydrogens and an oxygen, two hydrogens and an oxygen. Okay, if you were to circle, for example, H2O in another way, so if you said, oh, I've got two H's and an O, oops, sorry, like that, you would not get the mark. Okay, that's not where it forms. They need to be just straight across. That's not right because that's two H's and two O's. So you've got to be really careful that you get two H's and one O to form H2O. Okay, so those two hydrogens and that oxygen are removed to form water. So they are literally not attached on there anymore. So let's remove those. So where the glycosidic bond forms is between this carbon and this oxygen. And what you need to do is just draw the oxygen in the middle. So that's that oxygen I've just moved over. So I'll move that out. And then we usually draw the bond, the glycosidic bond, like this. All right. And then we should just say plus H2O. So we've now joined our two monosaccharides together. We've got a disaccharide and a water molecule. Okay, and this here is our glycosidic bond. Now we can label our carbons. So this is carbon 1, 2, 3, 4, 5, 6. And this is carbon 1, 2, 3, 4, 5, 6. So this glycosidic bond is going between carbon number 1 and carbon number 4. So that more specifically is a 1,4 glycosidic bond. All right, and that's what you need to know. You need to be able to draw that. So they might want you, for example, in an exam, draw it in full. I'm just going to draw it like this to make it quicker. They might draw them like that, and you might have to draw the structure here. So you draw out your full glucose like that, and then you draw your bond like this. Okay, so remember you'd have your hydrogens there. When we're doing like a quicker form of glucose, sometimes we might just draw them like this, just because it's quicker. So we just infer that we should just have an oxygen in that corner, sorry. It just infers the corners are carbons, and then it's not drawn out. It's just a bit quicker. Okay, so you could draw all of these on as well. In an exam, draw it all out in full with carbons and everything, but I'm just demonstrating what it would look like with your 2 monosaccharides and then your disaccharide on this side. And don't forget plus water on this side as well. Okay. Just check I've done everything. Yeah, that's everything. That's that spec point finished.